Good afternoon, everyone. My name is Sunil. I'm a product management director at Cisco. So welcome to this presentation on Cisco's IP Fabric for Media solution, which is in the front and center of this transition to IP that is happening in the media industry. And myself, I've been working at Cisco for a while, approximately 22 years, long time. Started as a programmer, now I'm a product manager. And I'm very specifically focused on building solutions for our media customers. And I've been working with media customers for almost 6 to 7 years now. So very much familiar with the industry here. Here is the brief agenda. We'll quickly walk over, I'll walk through the industry trends and the requirements these trends are imposing on the network that we are going to talk about. After that, I'll talk about the Cisco strategy in building how we are building the products to the specific problem or for media customers. Then we'll spend good amount of time on the architecture, the solution, the product, the capabilities, etc., etc. I'll do a quick summary and hopefully we will have time for Q&A. If not, I'm here, or you can catch me at the Cisco booth after the presentation. So with that, let's get started. The IP networking is the front and center of the broadcasters' mind, and this is very evident from the survey done by the Devoncraft guys, the market research firm. As you can see, IP networking, content delivery, 4K, and remote production recently made to top 5 in the list, right? So this is just a proof point that there is a lot of activity in the IP space in the media market. Also, what I want to do is to quickly show you when we talk about 4K, how these higher resolution formats and how these resolution formats map to the network and the flow sizes and things like that, right? So, for example, if you talk about full HD, when you have to transport that flow on the network, it's like approximately 1.5 gig or sometimes 3 gig. And you would need the port speeds of 100 gig at the time, right? But if you talk about 4K, the flow size increases to 12 gig. And if you talk about 8K, the flow sizes increase to 48 gig. As you can see, these resolution formats are really driving up the bandwidth. And this is where IP network plays a big role, and the speed at which the IP has been evolving is well suited to solve any of the networking needs for broadcast and media. Oh, sorry. Now, when we talk about IP networking, can we just take whatever we have from the Cisco product portfolio and just simply apply here to solve the media and IP workflows? Not necessarily, because there are definitely some unique requirements the media workloads and the media flows places on the IP network. First and foremost, what I want to talk about is the operator workflow. So today, the broadcasters are used to certain operator workflow, and if we change that workflow, then there will be a lot of time for uptake and adoption. So the number one requirement is that we do not change that operator workflow. The second thing is deterministic network. As you know, or as you can guess, IP is inherently unreliable. But for media and for the kind of things that you guys run, it cannot be unreliable. So how can we make this network very deterministic, very predictable, very robust? That's another requirement. And whatever the architecture that we come up with have to be flexible. We have to be able to deploy it in a big buildings where production is happening, or it needs to be deployed in OB vans and production trucks also in small setups. So the architecture needs to be very flexible. Security is very important. We should not be allowing anybody to join anywhere and then snoop, etc., right? We have to have robust admission control and policies. The other thing is visibility and monitoring. Networking, we have been doing networking for a long time. It is very intuitive, but for a lot of broadcasters, they're still learning, they're getting started on it. So how can we help them in this journey? By giving a lot of visibility and monitoring whenever there is any problem, any issue. And lastly, timing is so important for everything that you do. So precision time protocol is very, very key. And these are the key requirements when we look at building a solution for the media market. Before I jump into the product and solutions, right, what is our strategy? Number one, focus on open standards. Build the products to comply to open standards. Not only build the products, but also develop and participate in these open standards definitions, right? And we've been doing that on the networking side for a long time in IETF and some forums like that, and we want to do that same with the media standards. The second thing is the collaboration. Cisco equipment by itself is not the complete solution. It is only part of the puzzle. So we have to interop with rest of the equipment in the overall solution. So that interop and partnership is going to be key. The last thing is, our commitment to use the off-the-shelf hardware, or in the media terms, you call it a cart switch. But using the off-the-shelf hardware and software is very, very key to our strategy. This helps us to deliver the products and features at velocity, at scale. So with that, let me talk to you about, these are all the various standard forums that we are part of, and our engineers and principal engineers and distinguished engineers are participating, helping develop these standards. Just want to flash that slide. These are all the various vendors that we work with, and you will see a lot of familiar names, who are participating at NAB. We have these integrations and interops happening with all these various vendors. And lastly, I want to talk about our product itself, but before that, I just want to highlight that this is not something in conception, something early adopter phase or anything like that. This is in adoption now. We have crossed that chasm. If we were talking about 4 years ago, that's when the solution was new and we were still trying to adopt it and work through the problems, but we have gone through that phase now. We are in mass adoption. So these are the customers that gave me permission to put their name here, but we have good number of customers who have deployed it and using it in production today. Okay, and also we, Cisco side, use the same solution to broadcast our own events. This was Cisco Live in Orlando, which was broadcasted on the solution that I'm going to talk about, which is the IP Fabric for media. Okay. So with that, let me talk about the solution. What does the solution consist of? It has two key components. One is obviously the networking hardware, and for that we use Nexus 9000 or Nexus 9300 and 9500 series switches to form this foundation. And on top of that, we also provide a fabric controller, or what we call a media controller, so that it makes it easy from operations perspective. So both of them, again, like I mentioned, are not new products. These are from our data center switching portfolio. We just take them and then repurpose them, add some additional software components to it, so that these are very much applicable to the media space. Okay. Now, the hardware that we're talking about, Nexus 9300, which is fixed switches, FX, FX2, GX, these are all the various model names. They come in 1RU, 2RU, 4RU type of form factors, and these form the foundation. Also, there is a modular version of it, 9500, 4-slot, 8-slot, these chassis models as well. You can get them. All of them are non-blocking in the sense, there is no oversubscription anywhere whatsoever. So these switches are very well suited for running the media applications. Now talk about the Fabric Controller NDFC. It is a software application that runs on this appliance called Nexus Dashboard from Cisco. It's basically a compute cluster. And this application is a microservices-based application so that we can scale out as your scale increases. It's a 3-node cluster. For HA purposes, it communicates with various switching applications, so various switches out of band, or also even in band. And this application provides complete lifecycle management for Cisco switches so that you don't have to do this manually by yourself and you don't have to learn everything about switching. And this comes with a web-based UI, and it has a REST interface published to its northbound so that we integrate with our broadcast partners. For example, the Grass Valleys or eWords or EVS or all these guys integrate on top of that. Okay. Now let's look at how it will all fit together. Okay. Let's look at now how it all fits together, right? So at the bottom you have this IP network built off of Nexus 9Ks. That's where all of the endpoints and everything connects, right? Your cameras, microphones, all of your production equipment, all of that connects there. On top of that, you have the Fabric controller, the media controller that automates all of that. And on top of that, you have the broadcast controller, which is the authority for everything. And it consumes the network using the APIs provided by the media controller and sometimes also directly on the switches. Okay. So what do we mean by non-blocking fabric? And I also want to explain a little bit about the software enhancements that we have done for media market. All of the media flows, audio flows, all of them are multicast based. When we talk about IP terminology, right? And this multicast is blocking inherently in the sense it doesn't look at the bandwidth when it allocates flows on specific ports. So the enhancements what we have, so this is an example of showing it just picks up the flow path based on what we call an ECMP and based on some hashing algorithms. But this may result in some kind of oversubscription. So what we have done is implemented this thing called a non-blocking multicast, or nothing but bandwidth aware multicast, where for every flow, for every media flow, for every multicast flow that is coming into the system, we determine which path it needs to take based on the bandwidth available. And once that flow is set up, we reserve that bandwidth for that flow so that oversubscription will not happen. That's the goal. So that is crux of this solution, right? And this NBM, or non-blocking multicast, operates in different modes: active mode, passive mode. But this is all to keep the solution flexible. But the basic idea is that the NBM, or non-blocking multicast, running in the switches takes care of the bandwidth management. Sometimes it is also required that we expose this capability to our broadcast partners, and that's when we use it as a passive mode. And then essentially it allows us to deploy in different models. PTP is very important, and we support PTP at different levels. And we support the A67 profile, we support SIMT 2059-2 profile, and we are developing these various profiles, or media specific profiles, exactly for this market. And another thing that we're doing is to implement the grandmaster functionality on the switch itself, so that the switch can act as a grandmaster in some of the deployments. You can use this solution for remote site as well. For example, you can just have your camera crew and audio video endpoints in one site and transport all the flows back into your main site. And this is one of the popular use cases. The other thing that I want to point out here is the multicast NAT. Multicast NAT is very popular with our customers. You can do ingress NAT, egress NAT, unicast to multicast, multicast to unicast. You can do all kinds of things. So before, I can just point out to the use cases where multicast NAT is very useful. In this case, content distribution. You produce the content and you want to distribute it to various various distributors. So you can use multicast NAT and NAT the same signal to different multicast domains, right? Or for content ingestion, where you're getting the content from different providers, and then you can also NAT it into your environment. The other thing for other use case for NAT is if there is a receiver, it is not programmable, then you can actually keep switching the flows on the network itself so that the receiver doesn't need to change. The most recent innovation in the multicast NAT is this, which is multicast to unicast and unicast to multicast. This allows you to take the multicast flow, because the public cloud doesn't understand multicast. So what we need to do is take the multicast flow from your infrastructure and translate that to a unicast and then send it to public cloud, and then vice versa. So this allows you to do all of that. And by the way, multicast NAT functionality is implemented on the ASIC, on the hardware itself. So it runs at line rate. If you're using a port which is capable of 10 gig, it does at 10 gig throughput. If you're using a 40 gig port, it does at 40 gig, and it does at 100 gig, right? Multicast NAT is very powerful and implemented in a very flexible way in this solution. Security also very important, like I talked about. With this solution, you can clearly identify the policies from admission control point of view, who is authorized to join the network and who needs to be blocked. And then we can selectively do this. The second thing is flow policing. Somebody may be admitted, but how much can they send? How much can they consume? You can even define the policies and then continue to monitor them to see if they're exceeding any of these limits. So all of these are achieved through flow policies. The last thing that I want to talk about is the visibility and analytics in terms of feature functionality. Network is consisting of multiple nodes, but you, at a given point of time, you want to be able to clearly identify how the flow is going from point A to point B, which ports it is taking, which links it is taking. All of that, we will be able to lay that out in a nice user interface from the Fabric controller. That's the visibility part. You can have the same visibility applied to multicast NAT as well. You can see all the rules and everything and how the flow is getting duplicated or NATed. We can show you the PTP monitoring, who is the master, who is the slave, who is doing the corrections, and etc. All of that is a nice UI. The last thing in the visibility is the RTP and ADI flow monitoring. If a packet is going from point A to point B, if there are any packet drops, we can right away point out, because it goes through the RTP stream. We can pinpoint exactly where the RTP packets are dropping, so that it becomes really easy from troubleshooting point of view. All right, so deployment options are very flexible. You can do spine leaf, you can do hybrid, you can do a single switch deployment. So there are all kinds of variations that we support. You can deploy in a studio, you can do it in a stadium, it can be in a production truck. It's the same solution. It's the same solution that is applicable everywhere. Just gave some examples from the actual real use case point of view. In a live production studio, you could use the same solution. You could use the same in the production control room. You could use the same in master control room. Okay, I got a 2-minute notification, so hopefully I'm on time here. So in summary, you know, the time for transition is now. I'm seeing a lot of customers adopting this technology and then moving to IP. We are ready from our solution and Cisco IPFM side. And if you have any questions, feel free to talk to me after this.